In this video, we continue looking at deformed shapes of beams. The topic is drawing deformed shapes starting from a moment diagram, and we'll look at an example in this video. In a previous video, we went through the steps in detail, and we saw a simple example to illustrate those steps. This is a more difficult example. On the left-hand side are the steps that we've gone through previously. We need to determine the boundary conditions, consider the curvatures, sketch a trial shape, check that the trial shape respects boundary conditions, curvature, and continuity. If it fails any of those checks, we refine the curve and we start again. The example is sketched on the right-hand side. This is a segmented beam. The left segment is cantilevered, and it's connected by a hinge to the right-hand segment, which is propped up somewhere along the middle by a pin. There's a point load at the end. I've indicated in the diagram the continuity conditions. At the hinge, there's continuity of displacement, but because the hinge is free to rotate, there's no continuity of rotation or slope. At the pin, there's continuity of both displacement and rotation. The moment diagram is given. You could calculate this if you had to, but in this case, this is simply just given to you. In the next line down, I'm showing the boundary conditions, and I'm showing a straight segment, which corresponds to the undeformed shape of the beam. We'll use that to guide our drawing. Let's get started with the example, proceeding step by step. Step 1. Draw in points and slopes corresponding to the boundary conditions. I've drawn in a point at the fixed end and a point at the pin to represent the fact that those supports prevent vertical displacement. I've also drawn in a line segment at the fixed end to represent that the fixed end also restrains curvature. Step 2. We look at the curvature that's implied by the moment diagram, and we see that there are two segments of curvature. To the left of the hinge, the beam will be concave up. To the right of the hinge, it will be concave down. Step 3. Sketch a smooth trial shape. The shape that I've sketched here is probably the most common trial shape that I've seen when students are first learning this. It just feels right. You draw something that's concave up, you draw something that's concave down, and you make it go through points that are there on your construction lines. Now this is wrong, and we'll see why in the next step when we check. Step 4, checking the curve. Let's look at the boundary conditions. We satisfy the boundary condition for displacement at the fixed end, but we don't satisfy the boundary conditions for rotation at the fixed end, nor for displacement at the pin. So that condition is not satisfied. Let's look at the curvature. Concave up over the left segment, concave down over the right segment, and that indeed matches the shape of the beam that we've sketched. So that condition is satisfied. Let's look at continuity. Well, we previously identified the continuity conditions. If we look at the hinge, we indeed see that there's continuous displacement. If we look at the pin, we do see that there's continuous displacement and slope. So we have satisfied these conditions. We didn't satisfy all our conditions, so we're going to go back and we're going to refine the curve and check again. Here, I'm showing the previous attempt in a thin dashed line, and let's try to modify what we've drawn to satisfy all the conditions. We'll fix the rotation boundary condition. So we know that we not only have to start at that point, but we have to start with a horizontal slope. And the only way that we can start at a point and a horizontal slope and have upward curvature is indicated by the curve there. Next step, I'll draw in the hinge, and I'll draw in what's called the chord. The chord corresponds to the rigid body rotation of that segment of beam, and it's drawn in there simply as a reference line. Well, keep in mind that at the hinge, it's okay to have a slope mismatch. There's no continuity condition on slope or on rotation. And we'll use that when we sketch in the other segment of curve, which has to go through the hinge because there's continuity of displacement, and it has to go through the pin, And it has to be concave down everywhere. If we use all those three pieces of information, we get the curve that's sketched there. Let's drop out all the construction lines and let's evaluate this new curve. Boundary conditions, fixed displacement and rotation at the fixed end, fixed displacement at the pin, we're good there. Curvature implied by the moment diagram, concave up over that left-hand cantilevered segment, concave down over the rest of the beam, we satisfy that as well. Continuity of slope and angle where appropriate. We see that there's continuous displacement at the hinge and there's continuous displacement and slope at the hinge. So we've satisfied that condition as well. Now we've satisfied all our conditions, we're comfortable with our answer, and we're finished.